Welcome to another graphics lesson. This time we're looking at the parabola. So a bit of an overview on the parabola. For example, our McDonald's arch or the gateway arch we see here in St. Louis. And what you see here being electronically generated is the actual method for constructing a parabola. Now we use the rectangle method. And I'm going to go through that in detail, drawing it out in just a few moments. But I want to play it there for the moment as an electronic version so you can see what's going on as I talk about the parabola itself. So when generating a parabolic curve, any number of points can be used. In this case, in the case that I'll be drawing, I will be using 5 equally spaced points on the bottom half of the rectangle and 5 equally spaced points going up on the side length of the rectangle. Okay? Just to reference that gateway arch image, alright, it's 192 meters tall, alright. It has an iconic parabolic shape and is made from stainless steel. It's the tallest man-made arch structure in the Western Hemisphere, okay. So as they say, kind of this side of the world. Now, as we can see there, the electronic version of our parabola is forming, and you can see there that the Greek mathematician Menesimus in the mid-4th century BC is credited with discovering the parabola as a conic section. And a conic section is when you cut a cone at a particular angle of 45 degrees.
Hi everyone, welcome back to another graphics lesson. And what we're looking at today is the parabola. So we've looked at the ellipse, we've done, a couple of tutorials on that, and now we want to get into the parabola, which is another type of a curve. And unlike an ellipse, a parabola is a curve that, for want of a better term, it constantly diverges as it gets bigger and bigger, meaning that it'll never be circular or elliptical. It's always going to be a curve that's always going to spread from the point V, which is your vertex, and it's going to spread to infinity. So it's kind of a sad story that from the starting point, the curve on either side will never ever meet again. Okay? Now, we're using what's called the rectangle method. Okay? So the rectangle method is the typical method for drawing a parabola. It's not the only way. Alright? So we'll just note rectangle method. Now, what I have here is I have a rectangle. Okay? And I have a line going down the middle of my rectangle. Now, the measurements I have for this particular rectangle, and I'll just write them down here in a different colour here so that you can look back on them. The bottom is 100 wide, okay, and the side here is 150. Now, they can be anything, okay? Alright, I'm just using these two measurements as an example for you to do your own example, okay? So, we have a rectangle, 100 wide, 150 tall, and that's in millimeters, of course. Okay, if you're more familiar with centimeters, then that's 15 centimeters by 10 centimeters. So, what do we do from here? Well, once you have that rectangle drawn, you're going to draw a line straight down the middle. Okay, now, if this is 100 wide, what do we come in here? Half of 100, which is 50. Okay. So you'll come in your 50 millimeters or your 5 centimeters, draw that center line. Now, the top point here we're going to take as our vertex, okay? And the vertex is the point where the curve originates from, okay? Or turns around, or whatever way you want to look at it. And an example of this curve that you'd probably see every day is the McDonald's golden arch. That is based on a double parabola, okay? So you have two parabolas side by side, forming the M shape, okay? And then if any of you have been to St. Louis, which is in the United States, you'll see they have the golden, the arch, the gateway arch. It's a huge structure made of precast concrete, but it's also a parabolic shape. And then we think about how airplanes fly. Airplanes fly in parabolic trajectories. So, for example, if you were to take the shape of the flight of an airplane, track it, it would be a parabolic curve. Okay? So, all that said, how do we actually draw a parabola? Well, what we want to do is we want to focus just on one half of the rectangle now. So I'm going to focus on this left hand side here. And what I'm going to do is I'm going to divide this half here at the bottom into an equal number of parts, and I'm going to divide up the side into an equal number of parts as well. The key thing to remember here is, for example, if I decide to divide this bottom piece here into 5 equal parts, then I must divide the side piece here into 5 equal parts as well. So let me measure and see, can we divide it up evenly. So 50, if I take 5 equal parts, 5 into 50 is what? 10. So 10 millimeters, 10 millimeters, 10 millimeters, and 10 millimeters. Now, if that distance wasn't an even distance, then I would divide up that line using the line division method. But for us, we'll keep it nice and simple. We're going to go 5 tens there, and we're going to call that 0, 1, 2, 3, 4, and we'll call that 5. Okay? So I have my 5 equal parts there, each 10 millimeters. That's the unit. Now, if I go up the side here, it's 150. Now, if I divide 5 into 150, I get what? 30. Okay? Because if I have 5 parts down the bottom here, I want 5 equal parts going up on the side here as well. But it's not going to be 5 tens like it was here. It's going to be 5 30s, because 5 into 150. So I go 30 and do continuous measurement, 60, 90, 120, and of course there we have the bottom bit. So 0, 1, 2, 3, 4, 5. Now, so I have 5 equal parts on the side, I have 5 equal parts on this bottom section here, and what I want to do is I want to join each of the points that are on the side here, 1, 2, 3, 4, I want to join them to point V. Okay? Now, I'm not going to join 0 to V. You leave 0 where it is. 0 is already a point on the curve of the parabola. Likewise, point V. So we'll just focus on point 5 there is essentially when it comes across and it comes up, it gives us point V there. So point 5 is also looked after there as well. So we'll join 1 to V. We're going to join 2 to V. We're going to join 3 to V. And we're going to join 4 to V. Like so. Now what I'm going to do, use my t-square and z-square together, I'm going to join a line up from point 1 here at the bottom. I'll just straighten that up a little bit for you so you can have a look. So 1, and this is a vertical line, straight up. Make sure t-square, z-square together, line it up with 1 right here, and draw a line up to meet the line that goes from 1 to V. Okay? And what that gives me is it gives me point 1 on the curve of the parabola. Now I go to 2 and I draw 2 up to meet the line going from 2 to V. That gives me the next point on the parabola. There's 2. Then I go to point 3 here and I draw a line straight up from point 3 to meet the line connecting 3 and V right here. And then finally, point 4. I draw a line up from point 4 to meet the line connecting point 4 and V. And mark the point. And that is my point 4. So, we have 0, 1, 2, 3, 4, and 5, as I said, exists here at point V. Essentially, point V is point 5 for us here. So, when I'm drawing this curve, I very lightly, now you can start at the top and draw down, or you can start at the bottom and draw up. Doesn't matter, just the same rule applies as with the ellipse. Lightly first and look at the point ahead of you, okay? Because your eye and pencil will follow that. Okay, so like so. And when I'm happy with the shape of that, okay, then I can go and say, right, I'm going to heavy that in. So I'm going through point 1 there, on to point 2, 3, 4, and then on to point 5. which is point V at the top. So there now I have one half of my parabola. We can repeat the same on the other side, or you can apply this simple little trick. Okay? What we're going to do here is we're going to do what's called a transformation geometry, which is called axial symmetry, or we call it mirroring. Take your point 1 on the curve first. Take a line straight across and just extend these lines all the way across to the other side. 2, 3, 4. Okay? And of course we don't need to do 0 because we'll know that we'll have another point here. And of course we already have the top point. So how am I going to locate point 1 on the other side of the center line? Okay? So this is the center line. I have two ways I can do it. I can measure it and I can go, right, 1 is 40 millimeters from the middle line. Therefore, if I line it up with the middle line here, I can step it out 40 the other side. And there's point 1 in its new position, right here. So essentially we're taking the distance and applying it across to the other side. But here's the shortcut on that. You get your compass, where the line from 1 passes through the center line. Put the point of your compass on that point, stretch it out to 1, and then swing it over. And where the arc intersects the line, that's your point. So if I was doing point 2, there we go, point 2. Now swing it over, and I'll label it there in a second. Then I'll go point 3 and swing it over, and then finally point 4. And if the distance was too short for you, just measure it with your ruler and step it off like you did in the first place. So I mark the points like so. We're nearly there now, guys. So 2, 3 and 4. And then again I go with the pencil nice and light, and I draw my curve all the way down to point 0. Okay, I do it lightly first, okay, and you can see why there, and I mark 0 there, and now I just heavy in the curve like so. Okay, great. I actually missed point 2 there by about a mil. So that is my parabola complete then. And you know, I mean, for presentation purposes, you know, you can add a bit of a kind of a very light colour to the inside, a boundary colour as I call it, and you know, and you can start to imagine maybe that that's one half of the McDonald's sign, and wouldn't be a bad idea now for an old Happy Meal or something, given the times that we're in. Okay, so that is the parabola complete. Thank you.